Hey guys, this is part 2 from chapter 1, section 2 notes. So the last topic was to find x and y intercepts. So we're warming you up to do some graphing here. So no graphing in this section, but coming up real soon. So if you what's over in the box here, it tells you kind of what you need to do. Let me show you why really quick. If I were to draw a graph, imagine that was a straight line, x-axis. Imagine that was a straight line, y-axis. Not particularly good. And I were to say to you, hey, is this dot that I just drew an x-intercept? Imagine you would say yes because it's on the x-axis. And the coordinates for that guy would be 3, 0. Well, let me go over here on this side. Let me say, hey, would that guy be considered an x-intercept? And yeah, he's right on the x-axis. And the coordinates for that guy would be -5, 0. What do they have in common? They both have 0 as the y coordinate. So that's what this is saying up here in this box. If you were to plug 0 in for the y coordinate in an equation, you would find out what the x-intercept is. So let's go vice versa. Would you agree with me that that's a y-intercept? So the coordinates of that guy is 0, 4. What about that guy right there? He's a y-intercept. He's on the y-axis. His coordinates are 0, -1. So that guy, or both of those guys, have a 0 as their x-coordinate. So that is exactly what this box is saying. If you plug in 0 for one of the coordinates, you will find an intercept. So really, we get two problems to do. So a lot of people call this the cover-up method. So I can't really do that with a video. I can't literally cover up the 3x for you. But imagine that I did cover up the 3x. The only thing left will be the 7y equals -21. Okay, now on the other side of that coin, if you covered up the 7y, the only thing it would be there would be the 3x and the -21. So you can see one of the variables disappears because 0, if you plug in a 0, makes it disappear. So all we would have to do is solve these like normal, divide both sides by 3. There's my x-intercept of -7. Divide the other one by 7. I get -3. So there's my y-intercept and my x-intercept. It's that easy. Okay. So again, if I plug in, you can do them in either order, it doesn't matter. If I plug in 0 right there for that x, and I multiplied him out, well, anything times 0 would just go away. So it's like covering them up or making them, or ignoring them, making them go away. So I have the -y left. I have the 4 left, and just ignore the -2x. He's gone. Well, we just talked about this for standard form. If you want to switch the signs in a problem, it's legal as long as you switch them all. So I don't want to know what -y is. I want to know what positive y is. So I could just switch the sign and boom, I'm done. I've got my y-intercept at -4. Okay, now the other one is a little odd. Excuse me. So I can't just cover this guy up. If I cover him up, there's nothing there on the left side of the equal sign. So I'll at least write this, equals, and I got the 4, and I got the -2x. I hope it makes sense. If I want to find an x-intercept, it better be the x that's left over, right? Because at the end, it's going to say x equals a number, and that's what I'm shooting for. So that's why the box kind of comes in handy when people tell you about what's called the cover-up method. If I cover up the -y, I can't have an equal sign with nothing over here, right? So that's the whole plugging in 0. So on the initial one, on this, the one we solved for y, like, hey, if I plug in 0 here, I could just say he goes away, and I have something on both sides of the equal sign. But on this one, I really have to put the equal sign there, or I have to put the 0 there. And I'm going to solve it like normal. So how do I get the 4 to the other side? I subtract them. How do I get rid of the -2? I divide. And bingo, I'm done. So I got x by itself, and that literally is telling me my x-intercept. So plug in 0 or cover-up method, same thing. All right, for number 13, I'm going to do the x first, only because I have the blue marker ready to go. So again, I can't just cover this guy up because there'd be nothing there on the left side of the equal sign. So you can imagine I plugged in 0, that's what I would get. Solve like normal. How do I get the 18 to the other side? I add it. How do I get rid of the 5? I divide. Now, if you want to go decimal here, that's fine. Nothing wrong with fractions. We're not actually graphing these, so who cares what it comes out to be. So 18 divided by 5 is a reduced fraction, and I can use that for my answer. So I believe 3.6 would be the decimal equivalent of that. So if you want to go decimal on that, you're welcome to do so. All right, for the other one. So here's what we're talking about with cover-up. So I can do this. Like if I were to cover this guy up, he just goes away. So multiply by 0 makes him go away. What am I left with? I'm left with the 2y. I'm left with the negative 18. Solve like normal. And we're done. So I like to think these aren't that bad. Now 14, interestingly, the last one, it seems to, I understand there's a fraction there, but there's less stuff going on. And what should be the easiest answer for all ends up being missed a lot. So let's talk about the y-intercept first. Well, guys, how am I going to find the y? How am I going to get the y by itself if there's no y in the problem to start with? Well, I just gave you the answer. If there's no y in the problem, there's no y-intercept. Okay, please do not put no solution. Please do not put any of the funky symbols. I'm asking you what the y-intercept is. So there is none. You have to state that. There is no y-intercept. And if you go back over to my graph I was making over here on the left side, we'll show you exactly what that line would look like. What would happen if I drew a vertical line? Well, the vertical line definitely has an x-intercept. It crosses the x-axis, but when's it going to cross the y? It's not going to. So it's impossible to get one for that. So it's the easiest problem of all, but it tends to be the most missed one. So if there's no y, there's no y-intercept. If there had been no x, there would have been no x-intercept. All right, but speaking of the x, there is an x in that problem, which means we can find it. So I understand that we're supposed to say, hey, I'm going to cover up the y. There was no y to cover up in the first place. So if I were to try to plug 0 in for y, there's nowhere to do it. So I'm left with this. I'm left with the original problem. So for those of us who are extra smart, we know how to get rid of the 3/5 all at one time. But let's do this the two-step way. The two-step way is to say, I get a fraction bar, which means divide. And if I want rid of the divide, I would just times. 5s are gone. I got 3x equals 30. Easy from here. How do we get rid of the 3? We divide by 3. And x is 10. And that's it. That's how you find x and y intercepts. So most people remember the cover-up method, but not everybody remembers this deal right here. The reason you're doing the cover-up method is because you are plugging 0 in for one of the variables. And if you plug 0 in for one of the variables, it goes away. All right, guys, that's the conclusion of Chapter 1, Section 2. As always, thanks for watching.